I performed yet another experiment to know the pros and cons of different materials when they are used as a turbine for a hydro generator. This one uses the blower fan of the AC unit of a car, and towards the end I made a daring discovery about this turbine, which shows that even though it was made by the best engineers, it is not as perfect as it seems. So, this is the turbine of the AC unit of a car. It has 45 scoops that catch elements like water and air when those elements are blasted on them. I got this large wood to be the base of this hydro generator, the turbine and some PVC pieces. The large triangular pieces will hold the shaft of the generator as a bearing. I also got this gear and bottle caps that will be attached directly to the shaft of the turbine. I passed the shaft through the AC turbine and a bottle cap on one side of the shaft to act as a way to stop the turbine from tipping off the platform while rotating. I used super glue to keep them steady on the shaft and did the same for the other side. I then got the triangular platform and placed it on the board, securing it with super glue, and then another straight piece at the back of the bearing platform to make the platform rigid and strong to withstand the rotational force of the turbine. After securing it on the board with super glue, I got the AC turbine and passed one end of the shaft through the platform and the other end through the other platform, and secured the second platform with a straight support at its back and a super glue as well. Now, this is a generator that I've been using for quite some time now, made from the rotor of a mixer motor and the magnets of the starter motor of a generator. It already has a gear and 3 supports underneath it from the previous video. I got the large gear and pushed it through the shaft of the turbine and spun it to make sure that it doesn't shake. I placed the generator close to the turbine that the gears are in contact, but the wooden base of the generator comes in contact with the turbine during rotation, making the turbine to scratch on the edges of the base of the generator. So, to sort this out, I took the generator and used a saw to cut off the front edges of the base, removing a triangle from both sides, and this is how it looks. I then placed the generator back onto the board, and now the turbine doesn't touch the generator. I then secured the generator using super glue on all 3 supports of the generator onto the wooden base, and this is it all done. Time to know the outcome of the hours spent on this project. But before we spin the turbine using a hose and water, I wanted to know what it would give us when spun by hand. So I did that, and we can see that it gets up to 5 volts just from spinning it by hand, which tells me that it either is going to flat out on 5 volts or go beyond that. But there's only one way to find out. Let's move on to the hose and water. So yeah, it spins up very easily, and with the gear ratio, the generator was spinning much faster. But the question is, what can this hydroelectric generator made from the AC fan of a car actually do? So I'm going to connect these LED bulbs to the generator, and with the 5 volts we got from just spinning it by hand, the hydro generator should be able to light up the LED easily. Then connecting the first LED and working the generator with hose and water, It got me confused that the generator that made 5 volts by just spinning it with my hand couldn't power up this LED. At first, I thought I connected it wrongly, so I reversed the connection and the results are still the same. So I changed the LED with a smaller one and connecting it using this alligator clip. Spinning it by hand, the LED lights up very faintly, but obviously not very useful. I changed the contact area of the water and started spraying it on top of the turbine, thinking it would make a difference, but unfortunately it did not. But then I realized something off about the turbine. But before that, let's see how many voltage we're getting, since this hydro generator couldn't power up this LED. Connecting a multimeter, we can see that the generator is giving out around a maximum of 2.5 volts, which is far less than the homemade turbine that produced an output of 17 volts under the same conditions in the previous video. 2 volts is something, yes, but when it can't even light up an LED, then it can't do anything useful. That was when I discovered something about the turbine. If you look at this turbine, you will see that it has openings on the inside, unlike the turbine that I made that has a base for the scoops, which covers the other side of the scoops. So the water comes in from the outer diameter and leaves from the inside. That is why you see water around the inside of the turbine when it rotates. And the percentage lost in that process reduces the energy at which the water onto the turbine, and therefore losing the speed and strength it needs to rotate the shaft and the generator. Also, in this process, a lot of energy is lost when the water hits the scoops, since most of the water, around 70% of it, leaves through the gaps that are behind the scoops. Therefore, this is it for today's video on discovering ways to approach clean energy. Turn on your notification to know when the next one drops. Until then, don't just build, bend the rules while doing so. Make a mess, make some noise before you make some sense. Go check out my other videos, as I'm Emmanuel and this is Nexel Labs.